guys, and welcome to our 8th grade science series. Thank you so much for joining me today. We will start off with some physical science, move to life sciences, and then some earth and space sciences for 8th grade. So make sure to pause this, rewind this, watch as many times as necessary so you can become a pro, all right? So let's do this. Science rocks.
All right, it is super important for you to create a science notebook. So, whether it's online in Google Drive or straight up old school spiral notebook, you have got to take notes. So, take notes and draw pictures as you follow along. Go ahead and copy down these 24 vocab terms. They go in ABC order like this. And just come back later and create your own definition of these words. So use your own words, something that makes sense to you. Draw pictures, label them, or you can even use a funny app like Chatterpix or Shadow Puppets. So go ahead and pause this if you need to finish writing down these vocab words. All right, let's talk about chemical changes and chemical reactions. So, chemical changes occur when a material changes from one substance to another. And chemical reactions describe the processes by which these changes take place and can be represented by chemical equations that we'll look at in a little bit. So, whenever a chemical reaction occurs, the reactants have different properties than the products. There are a number of indications that a chemical reaction has occurred within a given sample. These include things like a change of color or maybe a temperature change, the production of a gas, maybe the formation of a solid. So let's talk a little more about each one of these. All right, so chemical changes. When chemical changes occur, new substances with different characteristics from the original substances are produced. All right, we've got color change. One way to tell if there has been a chemical change is to notice any color change. For example, when copper metal oxidizes or reacts with oxygen, it turns from a copper red color to a green color. All right, so the Statue of Liberty is one example of copper oxidizing. Although the Statue of Liberty now looks green, its original color was actually copper red. So, this color change is the result of copper and oxygen reacting and transforming into copper oxide. All right, and then we have temperature change. Another way to tell if there has been a chemical change is to measure and detect any temperature change of the substances involved. So, for example, when combining ammonium nitrate, let's say, with water, the temperature of the combination goes down because heat is absorbed in this chemical reaction. All right, so the temperature went down, so that was a change of temperature. And then we have production of a gas. So when baking soda and vinegar are combined, all right, maybe you've tried that, the production of gas provides evidence for a chemical change. Many bubbles form as this reaction takes place. All right, and then you have formation of a solid. It's another indication of a chemical change. So rust, here we go. Rust is a solid that forms when metal, such as a nail or screw, reacts with water. When chemical changes occur, new substances with different characteristics from the original substances are produced. So we've talked about how chemical reactions are the processes by which materials are changed from one substance into another. All right, these chemical reactions are represented by chemical equations. All right, you've got reactants. Reactants are the starting substances in a reaction. Reactants are on the left side, they're the starting substances. Okay, products are the substances that the starting substances are transformed into. They are the substances that are produced by the reaction. So they go after the arrow, all right? They're going to be on the right-hand side. So you have these reactants on the left, and they yield or produce the products. Okay, so in this reaction right here, this chemical equation, this would be an example of a chemical equation. You have two molecules of hydrogen gas. H is for hydrogen with a 2 on it. You've got the gas. So you have two molecules of hydrogen gas reacts with one molecule, okay? There's not a 1 in front of this oxygen. Okay, it's just known that there is one, you don't have to write a 1, there is one molecule of oxygen gas. The O is oxygen, with the 2 it makes it a gas. Okay, so you've got two molecules of hydrogen gas reacting, okay, or adding, with one molecule of oxygen gas to produce or to yield, okay, two molecules of water. H2O is water. So in this case, the reactants, all right, on the left, the reactants are hydrogen gas and oxygen gas. All right, what's the product? Water. Okay, so the arrow always points towards the products. Okay, it produces, it yields the products. Okay, coefficients. Let's talk about coefficients. The coefficients, or the numbers in front of each substance, indicate how many molecules of that substance are present. Okay, this is a coefficient. The 2 is a coefficient. There's two molecules of hydrogen gas. Okay, subscripts, or the small numbers that follow particular elements. Okay, this little one down here is subscripts. Okay, they indicate how many atoms of that element are present in a substance. Okay, so this 2, okay, this 2 down here is 2 atoms of hydrogen. Remember, the 2 in front of it is how many molecules. Okay, so the 2 in front of the H2 indicates that there are 2 molecules of hydrogen gas. The 2 that follows the H, this little one, the 2 that follows the H, indicates that there are 2 atoms of hydrogen in each hydrogen molecule. All right. If no number appears in front of the substance, like right here, there's no number in front of the O, the oxygen, assume that only one molecule of that substance is present. Okay, so the lack of a coefficient indicates that there is only one molecule of this oxygen gas. All right, this little 2, this little subscript 2 that follows the oxygen indicates that there are 2 atoms of oxygen in the oxygen molecule. All right, let's talk about some conservation laws. So, according to the law of conservation of matter, matter cannot be created or destroyed. It can only change forms. So, if one atom of chlorine is present on the reactant side of the equation, the left side, then one atom of chlorine must be present on the product side of the equation, on the right side. So the chloride atom can combine with different atoms to form new substances, but it can't disappear from the equation. Okay, it can't disappear from the equation. So, for example, let's consider the reaction of hydrogen gas and oxygen gas to form water. Okay, so let me write that out for you. We've looked at it previously. So you've got 2 molecules of hydrogen gas with 1 molecule of oxygen gas, and it's going to yield or produce 2 molecules of water, H2O. Okay, so this picture right here actually shows the same reaction using models of atoms in the reaction. Okay, although the atoms rearrange, there are 4 hydrogen atoms. Okay, there's 4 hydrogen atoms, and 2 oxygen atoms, okay, on each side of the equation. There's 4 hydrogens because remember there's 2 hydrogen atoms, but remember there's 2 molecules of it, so you have to do it twice. Okay, there's your 2 hydrogen atoms, and then there's your 2 hydrogen atoms. Because remember, there's 2 molecules of the hydrogen. With the oxygen, there's 2 oxygen atoms, so they're right here. Okay, now if you look at the right-hand side, there's still 2 oxygen atoms in blue, and there's still 4 hydrogen atoms in green. They're just rearranged. Okay. So this shows that atoms were not created or destroyed, only rearranged. All right. According to the law of conservation of mass, mass cannot be created or destroyed during ordinary physical or chemical changes. So if there are, let's say, 100 grams, we're talking about mass, 100 grams of a reactant on the left-hand side, then there's got to be 100 grams of product produced on the right-hand side, okay? So according to the law of conservation of energy, energy cannot be created or destroyed either. It can only change forms. So for a reaction that gives off energy, the energy of the reactants is equal to the energy of the products plus the energy released as heat. So for a reaction that absorbs heat, the energy of the reactants plus the heat energy absorbed from the surroundings is equal to the energy of the products. So all chemical changes and some physical changes involve either the absorption of heat or the release of heat. Reactions that release heat are known as exothermic reactions. And reactions that absorb heat are known as endothermic reactions. Okay, so let's just draw something out. We've got, let's use A plus B yields or produces C plus heat. Okay. Now, in this example, you've got 2 chemical substances that we're calling A and B. All right, they combine, they're being added together, they combine, and they're going to form or produce or yield this third chemical substance we're calling C plus heat. Okay, so in this chemical equation, heat is released. Okay, so it'd be an exothermic equation. So if you can draw out an endothermic equation, it would look something like this. You could do A plus heat yields B plus C. Okay, so chemical substance A has heat added to it, right? Has heat added to it. And it breaks down into 2 other chemical substances, B and C. So that would be an endothermic reaction where heat is absorbed from the surroundings. So science and engineering have been used to develop thousands of new materials that are not found in the natural world. So these materials are called synthetic or maybe engineered or maybe human-made materials. All right, things like plastic, glass, synthetic fibers, metals, wires, foods like margarine, ethanol fuel, and even medicines like aspirin. Okay, so synthetic materials are made from natural resources that have been combined or maybe altered in some way. All right, natural resources, remember, are useful materials that come directly from the earth, such as water, or from living organisms, such as crops. Okay, so cotton and wool are both natural materials that come directly from natural resources. And then you've got nylon and polyester that are synthetic materials that are made by chemically processing oils and other plant materials. All right, make sure to watch this video sometime about stoichiometry, aka balancing equations. Okay, let's do some practice questions. Number 1, when iron reacts with oxygen, it forms iron oxide or rust, right? So you've got this iron right here, that's Fe, reacts with oxygen, O, forms rust right here, okay? If 112 grams of iron, okay, so you've got 112 grams of iron, combines with 24 grams of oxygen, how much iron oxide is formed? All right, so go ahead and pause this and see what you come up with. So according to the law of conservation of matter, the total mass of the reactants, must equal the total mass of the products. Okay, so what's 112 plus 24? 136. All right, so 136 grams of iron oxide is formed when 112 grams reacts with 24 grams. So let's go with A. Number 2, in the chemical reaction below, sodium metal plus chlorine gas combine to form or to produce sodium chloride, which is actually table salt. So if the combined mass of the reactants, is 50 grams, so both of these together equal 50 grams, then the mass of the sodium chloride formed once the reaction has reached completion will be what? So what is the mass of the table salt, the sodium chloride? Okay, pause this and see if you can think of it. Okay, so the law of conservation of mass states that mass is neither created nor destroyed in a chemical or physical change, it's only rearranged. So if the combined mass of the reactants is 50 grams, then the mass of sodium chloride formed during this chemical reaction will be exactly 50 grams. All right, so that would be A. Number 3, in a chemical reaction, the reactants are the substances that undergo the reaction. They're on the left-hand side. And the products are substances that are formed during the reaction. They're on the right-hand side. So this info below shows the reactants right here and the products right here of several different chemical reactions. Okay, so you've got reactants here. Here's a product. Notice that heat is being released, and the type of reaction is exothermic. Here's some reactants with their products. Notice heat is being absorbed, so it's endothermic. Here's reactants with their products. Notice heat is being released, so it's exothermic. And here's the last reactant with its products, and heat is being absorbed, so it's endothermic. So based on the information in this table, the best definition of an exothermic reaction would be what? Okay, remember that exothermic reactions release heat. Okay, it gave you all that info and you really just needed to know what is an exothermic reaction. It's a reaction that releases heat. So A. Remember, endothermic reactions absorb heat. Okay, and remember that heat can be listed as either a reactant or a product, whether it's endothermic or exothermic. Number 4, ethanol contains the elements of carbon, that's the C, hydrogen, the H, and oxygen, the O. So when ethanol burns, it chemically reacts with oxygen gas. Okay, what elements will be present in the substances that are created when ethanol burns? Okay, when a chemical reaction occurs, the atoms in the original set of substances, remember, can be rearranged to form new substances. All right, the number of atoms in each element does not change, but the elements of carbon, hydrogen, and oxygen are the only elements present in the original substances. So the only elements in the final substances, okay, whatever it has to be composed of carbon, hydrogen, and oxygen as well. So that would be D. Number 5, an engineer is designing a process to cool hot water from a power plant before returning the water to the environment. So his plan is to allow the hot water to flow past a pipe containing a solution that is undergoing a chemical reaction that will cool the water down. The chemical reaction will be able to remove some of the water's heat through the metal pipe. All right, so which of the following reactions could take place inside the cooling pipe to remove heat from the hot water? All right, so in order to remove heat from the hot water, the engineer needs an endothermic chemical reaction in the cooling pipe. Okay, remember endothermic reactions take the form of adding heat, okay, because it's going to absorb that heat. It doesn't want to produce heat, it wants to absorb heat. So if you look at our choices, the only equation that is absorbing heat is B. Okay, all these other equations are producing heat. We want to absorb it in order to cool the water down. So we'll go with B. Okay, you will see questions set up kind of like this where it gives you a bunch of information, maybe even a picture or a graph or a table, and then it asks 2 or 3 questions over that same info. Okay, it's called a cluster. So let's practice doing that. Study this information, then answer questions 6 and 7. Students were learning about chemical reactions. They learned that there are reactions in which one molecule breaks down into other molecules or atoms, and many of these reactions have useful applications. So, for example, a chemical called sodium azide, and I'm noticing, okay, NaN3, the little 3 should actually be a subscript. So it should be NaN3, like that. Can break down into sodium metal, which is Na, sodium, and nitrogen gas. And this into nitrogen gas, the 2 should be a subscript. So it's actually written like that. Inside airbags in cars. Okay, so the nitrogen gas is what fills the airbag. Okay, as another example, you have water molecules, H2O, which you know the 2 should be a subscript, so it's H2O, can break down to form oxygen gas. Okay, this O2, the oxygen gas, should be a subscript, as well as hydrogen gas. That little 2 should be a subscript. Okay, the students wondered how much oxygen gas and hydrogen gas are produced when water breaks down. They wanted to find out if they could predict the amounts based on a model of the reaction. All right, so they used the information they had learned to develop this model right here. Okay, so they developed the hydrogen atoms with the little white circles. Okay, remember there's 2 hydrogen atoms, but there's 2 molecules of it, so there's 4. And there's the same amount on the right-hand side, the products. And then the oxygen atoms, okay, it starts off with 2 of those, and there's also 2 on the right-hand side. So they created this model. Okay, so right here you just see all of this information, and then we'll go on to the actual questions of number 6 and 7. So still thinking about all of that information, you've got number 6. What does the student's model show about the relationship between the numbers of atoms present before and after the reaction? Okay, so pause this, read through it, and see what you think. Okay, I'm going to go with C. The total number of hydrogen and oxygen atoms before the reaction is equal to the total number of hydrogen and oxygen atoms after reaction. And then we have number 7. So you're still thinking about that original information. The student's teacher asked them to use their model to make a prediction. The students need to predict the total mass of hydrogen gas and oxygen gas produced when 2 grams of water break down. Okay, so based on the student's model, what's the best prediction for the mass of the products of this reaction? Okay, remember it's the same, so we need to go with A, 2 grams. So, after fully mastering chemical reactions and synthetic materials, and you feel like a chemist, you should be able to create a project or a presentation, experiment, a model, something to explain all of this to your teacher. So, I challenge you to do that. Ready, go.